Hey, this is the application development team. How are you?
Good. Good. You?
Peachy. So, I have a request.
Okay.
Please tell the network team that we need port 80 open on 10.1.1.1.
Sure. No problem.
Did you write that down?
Nah, I'll remember.
Great, thanks.
Hello? Hey, it's Ned. I've got a request from the app dev team.
What is it?
Geez, let me see. They said the port of Haiti was open and fun.
Okay. I thought we were going to Barbados, but whatever.
Hey, that's what they said.
All right. I'll get the tickets. Can you tell them the tickets are taken care of?
Sure.
Thanks. Weird.
Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. So glad you are here. Today's topic, we're going to be talking about Consul Terraform Sync. And you might not know what that is. You might not have even heard of it, but don't worry. We're going to get into what it is and why you might use it in a moment. Before we get into that, just a quick reminder, I do have a Patreon going. So if you're interested in supporting Terraform Tuesday and some of the other stuff I'm doing, as well as getting a weekly newsletter from me, you can hit that up on Patreon. The link is down in the description. Aside from that, other things are going good. It's Tuesday. It could be Taco Tuesday wherever you are, and it's Terraform Tuesday here. So let's jump right into what we're talking about. You know, as we saw in the intro, you're going to have situations where you've enabled a new application or a service or something, and there's components of your infrastructure that are not as dynamic as you might want them to be, especially if you're in an application development role or if you're managing something like Consul. You have a new service that pops up and you want to expose that service through a load balancer that maybe isn't plugged into your whole environment. What if you could control that infrastructure through some sort of synchronization process? What if you could leverage the power of Terraform and the service discovery capabilities of Consul to create a workflow that unified those two things? Cats and dogs living together. Oh my goodness. That's the core idea behind CTS, as I'm calling it, Consul Terraform Sync. It's a bridge between what's going on in Consul and what's going on in Terraform, and using Terraform to reach out and manage some of those devices out there. So obviously you need a device that has a Terraform provider. If you don't have that, you're kind of dead in the water. But assuming that you have a device that has a Terraform provider for it, and you have services you want to expose through Consul, now you can use CTS to be the bridge. So let's walk through that a little bit with some presentation slides. Don't worry, it won't be much, and then we'll get right into the demo. Now, as I said, CTS, Consul Terraform Sync, is meant to be a bridge between two different things. And for whatever reason, whenever I say CTS, I think of a duck. And so I'm choosing to use a duck here to represent CTS. Now imagine that you've got Consul over here, and Consul is there to do service discovery and advertising. It's controlling some DNS stuff. It's doing what Consul does, and that's cool. Now on Consul, or I should say, there's a web service that's leveraging the Consul agent. So when that application comes up on its server, it goes ahead and registers itself with Consul. All good. Now let's say that somewhere over to the left, I've got a load balancer that I want to expose this service, or a pool of servers that have this service, to the wider world. Whether that's internal or external doesn't really matter. The idea behind CTS is it's going to constantly monitor what's going on in Consul. It's reaching out and it's accessing Consul and saying, hey, anything change? How about now? How about now? And if anything has changed, that kicks off a workflow within the world of CTS. CTS is going to reach out. But how does it reach out to that load balancer? How does it talk to that load balancer? What is it going to do? It's going to use Terraform to do that. It's going to use modules from Terraform and the provider associated with that load balancer to push an updated or a new configuration to that load balancer. And it's also going to need to keep track of Terraform state. Where could we put that? Well, I mean, you could put it in all of the usual places, but you already have Consul running, and Consul's a supported backend for Terraform, so why not just use the Consul instance as the backend for Terraform by default? Now, you can adjust that obviously, but it's kind of convenient that it's already there, right? So that's the basic idea behind CTS. Now, what sort of information does CTS need to have this whole workflow going? Let's explore that a little bit as well. CTS is running as a service, and it needs a configuration file to tell it what to do. Now, obviously, because this is HashiCorp, that configuration file is going to be in HashiCorp configuration language v2, though I believe you can also do it in JSON, but why would you unless you hate yourself? So some of the information that needs to be in there is, first, it needs to know how to reach out and talk to the Consul instance. So you're going to define where to find Consul, as well as credentials to access Consul. You also need to tell it which services to pay attention to on Consul. You might have a bunch of services there. Now, it does support like an auto-discover feature. It'll discover all the services, but if you want to explicitly name services to watch, you can do that as well. Now, once it sees services, it needs a workflow, and part of that workflow is tasks. What do you want CTS to do when something changes about the services it's watching? You also need drivers to do the thing that's defined in the task. And usually this is going to be a Terraform driver. Now, the idea here, I think, is eventually this could expand beyond Terraform to invoke other actions, but right now it's really just Terraform. And then lastly, you need to provide a config that it can load into Terraform to go talk to whatever devices you want to control. So that load balancer is going to use a Terraform provider. And that provider is going to need to know where to find that load balancer device and credentials for talking to it. So you're going to need to define those as well. So all of this information is going into that configuration file. So for the demo, let's take a look at what we're actually going to deploy. And we're going to use Microsoft Azure to do it because, well, Microsoft MVP, I get free credits. It's the easiest way for me to do stuff. But let's take a look at what we're going to deploy in the demo and how it's going to all interact together. And then we'll jump over to Visual Studio Code and walk through the actual demo and configuration process. All right? Okay, so here's my little diagram about what we're actually going to deploy in Azure using Terraform to set up CTS. Now, hopefully you're with me so far. All right, so we're going to have a VNet in Azure. We're going to deploy that as part of our configuration. And within that VNet, we're just going to deploy a single subnet. Okay, sounds good. And in that single subnet, the load balancer I've decided to go with is the F5 Big IP load balancer. Why? Well, it was one of the supported providers that comes out of the box for CTS, and I thought, well, it's already supported. It's available in Azure. Why not use that one? So it really didn't go any further than that. And then we're going to deploy a second Azure VM. And on that Azure VM, we're going to deploy Consul, our web application that's going to be doing stuff. We're going to install Terraform, and we're going to install CTS. So all that's going to happen on that other virtual machine. Obviously, you could break these things up, but it was easier to just deploy 2 VMs than a whole bunch of them. Now, we're going to have 2 public IP addresses, one that's associated with the load balancer and the other one that's associated with the Azure VM running CTS. In order to access the web application from the client, we would go to the public IP address of the F5 load balancer. And for that load balancer, we're going to need to open a few ports. We're going to need to be able to SSH into that thing to do initial config. 8443 is the management page for it. And then port 80 is the port that will actually expose our web service on. For the public IP address of the Azure VM running CTS, we're going to have to open a few ports there. Port 22, so we can remote in and configure this thing. We're going to need 8500 because that's the port for Consul that it runs on by default. And then port 80 will be the web service, but that we're really just exposing that to the load balancer. I do have it open to everything for testing purposes, but you could just expose it to the load balancer since that's our web application. When CTS fires off, it's going to be running from the Azure VM. So it's going to reach out over port 8443, This is Terraform doing this work now. So CTS is going to kick off its task. It'll invoke Terraform. Terraform is going to use the F5 provider, reach out to the load balancer, and update a configuration file on there to create the entry on the F5 load balancer for the web service running on the Azure VM. So that's the whole idea. Once that's done, the F5 will now know about the web application running on the Azure VM. And when requests come in for port 80 on the F5 load balancer, it's going to send those requests over to the web service running on the Azure VM. So hopefully that all made sense to you. Now let's get this thing deployed and working in Azure using Terraform. All right, here we are in Visual Studio Code, and I am working in the folder 2021-0309 console Terraform sync. Yes, I kind of set this up a while ago, and it's taken me a little while to shoot this video, so that's why the date is so far in the past. But at any rate, it is all working, and if you're looking for these files, you can always find them on my GitHub repo. The link should be popping up right about now. There we go. All right. Now, if we expand this folder, in there, I've got a README file that you can follow along with, as well as an environment directory that has all the Terraform configuration stuff in it. Now, if you're following along, here's what we're going to do. Deploy an F5 load balancer in Azure, deploy a VM running all of those services we just talked about, register an app with console that's running on the same server, and then have F5 open port 80 on the load balancer to that app using CTS. So what do we need to do as a sort of a prerequisite? The F5 load balancer VM image we're using is a pay-as-you-go marketplace item on Azure, which means you have to agree to the terms of service for that marketplace item before you can deploy it programmatically. You can do that, and I have it in Bash right here. If you log in, using @az login, and then you run this command against the subscription you want to enable it for, it will accept the terms for that specific image, and then you'll be able to use Terraform to deploy it. If you don't do that and you just try to deploy directly, you're going to get an error saying you haven't accepted the terms yet. So just bear that in mind. After you do that, the next part is very simple. Simply deploy it using the standard Terraform init, a plan, and apply. And you can skip the plan if you're the type of person who wants to skip the plan. The files are in the environment subfolder. So why don't we take a look at what's actually in those files first? So I have the environment directory expanded here. There's a single main.tf file. So let's scroll up to the top here and take a look at what's going on in here. We have some variables laid out. I'm using East US as my default location. You can change that to whatever you'd like. And for the big IP password, I had to set it to something. You can override this as well to whatever you'd like. We're using the Azure RM provider, so that's all good. I'm setting some locals. We're going to generate some SSH keys specifically for this project. So this will generate new SSH keys that you can use. And I write the private key out to a file that we'll copy into our .ssh directory in a little bit. Create a resource group, create a VNet using a module, and then I actually wrote a module for deploying the big IP appliance, the F5 appliance. We can dig into that module in a moment, but let's see what's going on beyond that. We're going to create our CTS virtual machine. So we need a public IP address for that. We need a network interface. It's a Linux virtual machine, so we're deploying the resource Azure RM Linux virtual machine. And within that, I'm picking size D2 V4. That's plenty of bulk for what we need. If you want to change that size, you can go in and change it, but accepting the default is probably the easiest thing to do. If we scroll down a little bit more, we get into the source image. So I'm using Ubuntu 18.04. Again, if you want to go in and change this, I hard-coded it because I don't feel like changing it. You can do whatever you want. And then lastly, we have a custom data file that we're sending to this virtual machine that will do the actual configuration. And I prefer this versus the remote exec provisioner because it doesn't require that you open port 22. In our case, we are opening port 22 because we need to do additional config afterwards, but you could do this all through custom data and not open that port. So that's why we're doing that. Let's scroll down a little bit more and we get into our network security groups. This is where we open up the necessary ports. So we're doing port 80, we're doing port 22, and we're doing port 8500 for console. And then we also have to output the public IP address of both the Azure VM and our big IP. Let's take a look at what's actually in the cts.tpl file. That's the file that is the template for our custom data that we're sending to the Azure VM. This is relatively straightforward. The first thing we do is add the repository for all of the HashiCorp products so we can install Terraform using apt install. So we'll do that, and we're going to install Terraform, Consul, JQ, Unzip, and Apache 2. Apache 2 is going to be the web server that we're running for our demonstration. And then we have to install Consul in this thing. So there's a bunch of commands essentially to get Consul installed, and a very basic config that just listens on the address 0000, and we are enabling ACLs. So this allows you to issue tokens for access to Consul. If we scroll down a little bit more, we create the Consul service for systemd, and then we get that Consul service running. Now, because we enabled ACLs, and you don't need to be a Consul expert by any means, I'm certainly not, but because we enabled ACLs, we have to bootstrap that ACL and get the token back. So in order to do that, I'm going to run the Consul ACL bootstrap command and then output the information to a file bootstrap.token, and then I'll read back in that token value into secret ID. And then I'm going to export the secret ID. This is my bootstrap token that can do anything. It's basically like a God permissions on Consul. I'm going to put that in an environment variable so I can do some Consul config. Scrolling down a little bit more, we need to get our Apache web service, which is already running because it starts running when you install Apache. We need to get the local IP address so we can register this Apache web service with Consul. So I'll get the local IP address, and then I'm going to do Consul services register. That's the command to register a service with Consul. And I'm going to give it the local IP address. And then there's some additional fields that are required by the module and provider for BigIP. And these are basically just metadata that it's going to look for when it goes to register that service over with the BigIP. We need to set the VSIP, that's the virtual server IP address, the virtual server port, VS port, and then what template to use. So they use this thing called AS3 template language on the BigIP, and we're going to use the HTTP template from that to create this service, which is just a standard HTTP service. Okay, so we have all of that. That service is now registered with Consul. Below that, we are going to create a token for CTS to use specifically on Consul. So we're not going to use the bootstrap token for CTS. We're going to have CTS use its own token when it's running as a service. So we're going to use the Consul ACL token create command and then store that token value in cts.token. And then we'll extract the token value into a variable CTS token. And then we're going to create our CTS config file. So you remember when I talked about earlier, CTS needs a config file to know what to do, and it's in HCL. This is that file. So we're going to set the port to 8558, which I believe is the default port it uses anyway, but we're going to say explicitly that's what it is. And then we have to know how to talk to Consul. Okay, so there's a block to talk to Consul. It's running on localhost, so that's all we need to tell it there. And then it needs a token to talk to Consul, and we'll set that to the CTS token that we've generated. Awesome. Now we can talk to Consul. That's all good. Now, what services are we interested in running on Consul? Well, I created a service called Web a little further up in the script. That's the service we care about. So I care about the service called Web in the data center DC1, which is the default data center for Consul. And I give it a little description too. Now that we know what service we're interested in the web service, we have to create a workflow around that service. And that is where tasks come in. CTS is task driven. And basically we want to say when something changes with that web service, I want you to do something. So we're going to give that task a name. We'll call it F5 and a description. We'll set enabled to true because we do want it to actually do something. And then we can give it a list of services to look at. The only service we care about is web. So we put web in there. Providers, this is where you tell it what providers and modules to use to accomplish whatever the goal is. So this is not necessarily the provider in the sense of the provider plugin. This is the provider in the sense of the module you want it to run. So there could be a little confusion there. This should probably actually be modules and not providers, but it is what it is. So we're going to say BigIP. We're going to call it BigIP. And in the source, we're going to point it where it can find the module for this automation task. And that module is found on the official Terraform registry at that full source path. So it's going to go to the Terraform registry and download that module for the Terraform configuration. And the module has a version. The current version right now is 0.1.2. So that's what I set in here. If they rev it to 0.1.3, feel free to change this. Now, what driver are we using to accomplish this task? Well, we're using Terraform. I mean, it's really the only option right now. Eventually, maybe they'll add other drivers, but Terraform's the one. So we'll set the path to Terraform. It needs to know where it can find that Terraform executable, or if the Terraform executable isn't present, it'll actually download the most recent version of Terraform for you, but we've already installed it, so no big deal there. It's in user bin. That's where it can find it. And then the required providers here is the actual provider it's going to use, the provider plugin it's going to use in the Terraform config to accomplish any tasks. So in here is where we say big IP is the provider we need, and we'll point it to the source that's on the Terraform registry. So we've got a module defined in the task and the actual provider defined in the driver. And then we have to provide some additional configuration information for that provider. How does it talk to the big IP? That's under Terraform provider. That's a separate configuration block, and we need one for each of the providers that we list in the driver. We just have big IP. So under address, I have the big IP's address. I've already figured out what that is and submitted it as part of the template. And it's going to talk to it on 8443. The username is going to be admin because I'm not creating an additional account. And then the password will be that password that we have set in the variable for the configuration. Okay, so we have all of that. And then beyond that, we have some additional commands here. We're going to set the version of CTS to whatever the current version is. Right now it's 0.1.0. This is very much beta. We'll use wget to go get that version. We can unzip it and then place it in the correct location, and that's it. Now, we're not actually going to kick off console Terraform sync from this script because we want to do that manually once we have everything set up and configured. So that's everything that's going on when we launch that Azure VM. This whole template gets rendered and passed to the virtual machine. And really, the only settings it needs, if we scroll back up to that configuration, we're going to pass it there it is. We're going to pass the big IP address and the big IP password to fill out that template. Okay, so that's everything that's in that template. The very last thing is the module to deploy the F5. And I got to tell you, it is extremely boring, but I might need this some other time. So I have it laid out here. I can use it later. And this is really just setting some very basic stuff. What's the image reference that we're going to use here? We create a security group for it, the security group rules for it. We create a public IP address, a network interface, and then we create the Linux virtual machine referencing that image that we had further up. Because this is a marketplace item, we can refer to it by image. And we also have to add a plan because it's a marketplace image. And then we push out the private and public IP addresses because we need those in this main configuration. The private IP address goes into the template, and that public IP address is one of the 2 public IP addresses that it delivers as output. Now, I've already taken the liberty of running this. So we have our 2 public IP addresses right here. And if we go to the CTS public IP address on port 8500, that gets us to console. So let's bounce over to that real quick. This is the public IP address of the console. And you can see under services, we have 2 services already running. We've got the console service and we've got the web service. That's exactly what we would expect. If we take this same public IP address and we open it up on port 80, we get the Apache 2 default page. So this is going directly to the Azure VM, but we want to publish this through the F5 load balancer. So let's go back and walk through the next series of steps together to get that accomplished. All right, we're back in Visual Studio Code, and let's go back to the README and see what the next step is here. Now we've run through deploying the infrastructure. Now we want to update the F5 config. We have to set the initial password because that's not something you can script out apparently. So we're going to need to SSH into it to set that initial password. So I'm going to copy the private key that was created by the Terraform config into my SSH directory. So I'll go ahead and do that now. There we go. All right, and now I have to change the permissions on that key so SSH will let me use it. We'll do that. Okay, and now we're going to connect to that F5 load balancer using the admin account and using the public IP address of the load balancer. So let me just grab that, paste it in here, and then we're going to point it at the key that we're going to use to make that SSH connection. And I'll go ahead and accept. Yes. Okay. So now we will be connected in, and it's going to put us into its TMOS interface. All we have to do is run this command to modify auth password admin. So go ahead and copy that, paste it in here, and now it wants the new password. So let's go back to here, and we have to set this to the same password that we used in our configuration. So if you change this to something else, make sure you're using the correct admin password. So I'll paste it once. I'll paste it a second time. And there we go. Our password on the F5 load balancer is now updated to match what's in our CTS config. So the two can now talk to each other and I can get out of here. Oh, quit. Apparently I have to say quit. Sure, why not? All right, let's go back to the README. We are out of the device. Now we have to install the AS3 template engine because that's not installed by default. So I already have the link here. I can simply grab it. Go ahead and run that. That'll grab it. And then we have to set some variables here. So we have to set the creds, and the password here is not correct. So let me go ahead and grab that password. And you have to change this to whatever you just set that password to in order for this next set of steps to work. We also need the public IP address of the big IP. If I scroll up far enough, I can grab that. I'll go ahead and grab that and paste that in here. All right, we've got that set. So we're going to go ahead and set the FN variable to the version of the template we're going to install. We'll set up our creds. We're going to register the public IP address. And then we need to do a little bit of other stuff to get it ready. And now we're basically going to upload this file to the F5 load balancer and have it run some operations against that file to get the AS3 template engine installed. Yes, I know it's a little bit annoying, but that is the way that it works. So, all right. Fortunately, all these directions are available on F5's website, so I didn't have to figure this all out on my own. But there we go. We've now uploaded the file, and now we're going to execute that file to get that thing installed. And it looks like, yep, looks like it is happy now. So we've registered it, and the last thing to do is just remove that local package so it doesn't sit in your repository, crufting stuff up. Okay, the F5 is all set now. It's very happy. The next thing we're gonna do is SSH into our Azure virtual machine. And in order to do that, we'll need that public IP address again. So I'll just do Terraform output to get the public IP address of our CTS, and we'll do SSH and use Azure user is the username that I used. And we'll put in the public IP address. There we go. And then we'll set it -I, and didn't expect to be typing this. Probably should have put a command in there, huh? There we go. All right, so that should work. And we're now connected to our CTS virtual machine. All right, awesome. Now, everything else should be set. Our configuration file should be all set and ready to go, so we can kick off console Terraform sync. All right, so it is running, and it's flashing by pretty quickly. So once this finishes, we can scroll back up a little bit to see what actually happened as it was running this command. So I'm going to pause here for a second and wait for this command to finish so you can see what it did in its process. All right, so it finished, and I'm not gonna lie, I'm glad I paused this because it failed the first few times. Did I mention that this product is beta? It is. Some of this might be issues with the provider, some of it might have been issues with the F5, but it did eventually succeed. It had to run 3 times, and I don't want to scroll through everything it did. But essentially, if we scroll up a little bit here, we can get an idea of what was going on here. So if we scroll up to the beginning of this specific run, and get up to the top. Okay, there we go. It started its run, and it lets us know that Terraform is already installed. So we're all good there. It sets up a controller. It tests its connection with console. That's all good. So it's happy with that. And we scroll down a little bit, and it starts writing its configuration. So it initialized the driver, and now it has some tasks to do. it's going to execute that module that we passed it for the F5. So it's going to start the task F5. And in order to do that, it's going to run Terraform init. So it runs Terraform init to download the providers. And if we scroll down a little bit here, we can see that the Terraform providers were already installed because this had to initialize 3 times. So the last initialization doesn't change anything because the providers are already all there. But here's the full command it's running. It's running Terraform init. It installs the modules, the backend, all that kind of good stuff. It warns us about an interpolation-only expression, which shame on you, F5, you got to fix that. And then if we scroll down a little bit, it tells us the initialization is all good. And then it's going to run the full Terraform apply command. So it creates a workspace, it selects that workspace, it runs Terraform apply. That apply is going out and talking to the F5, and then it just waits until everything is successful, and it is eventually successful. It creates the information on the F5, and then because I launched this with the little @ sign at the end, as you can see, it's now sitting and just running as a service, waiting for new changes to happen on that web server. Now, if we go over to the F5 interface, the big IP interface, there we go. And if we go to, I believe it's local traffic, and we go to virtual servers, if we go to the virtual server list, it's going to say there's nothing there. And you might be like, what? I just did all that work and there's nothing there. And it took me a while to figure this one out. You have to hit the partition drop down, and it creates a separate partition specifically for the console Terraform sync service. And here's the actual service that's running. It is listening, and it's listening on port 80. So if we go to our IP address here, the public IP address of the F5 load balancer, it'll load the Apache web page. So it was successful in the sense that it created a virtual service with the correct port using all the metadata that we associated with it. It was able to do all of that with the F5. And this is obviously a very much a proof of concept sort of thing, but you could see how you could automate a lot more of your environment with this console Terraform sync if you're already using console for service discovery. If we go back to Visual Studio Code, if you want to test the update process, you can absolutely do that. You have to go into console, just make an update to the registration of the service with some slightly different information. CTS is going to catch that information, and it's going to kick off another round of changes. And because it already has state stored, and it knows about the F5 and what the current state is, it's going to update that state with whatever the new settings are that you've added. In this case, we're changing the services address from 10.0.0.4 to 10.0.0.10. So I leave that as a challenge for you to go ahead and run that, because this video is already running a little bit long. So let's talk about what we covered today. We took a look at the CTS product. I don't know if I call it a product, the CTS feature that HashiCorp is developing. And we saw that you can use CTS to monitor what's going on in console and then apply changes via Terraform, a module and a provider, to network infrastructure that you have that might not be tied nicely into console. So you're basically creating an automation here using Terraform, and console's serving as the list of services. It's the source of truth, and then Terraform's doing its thing. So that's the basic idea. That's what we saw today, and we walked through the full demonstration, so you actually got to see it in action, and you can go find those files and run it yourself and get the same result. One word of caution, I have seen that the F5 sometimes takes a while to install that AS3 template. So if you try to run through it like really quick, the template might not be fully installed yet, and so you might fail the first time. Keep running the CTS sync, and eventually that AS3 template will install and the rest of the process will run smoothly. And I'm sure there's going to be new versions of the provider module and this CTS executable, so keep an eye out for those as well. That'll do it for me today. Thank you so much for watching. Hey, if you made it to the end, congratulations. I know this was a little long, and that's probably why it took me so long to record this, because there was a lot of information to pack into here, but I hope you enjoyed it. If you have questions, suggestions for future shows, let me know in the comments or hit me up on Twitter. It's Ned1313. If you want to support this type of video and other stuff like it, why not become a patron? You get early access to this video, so that's kind of awesome. You also get a weekly newsletter, and you just get my undying thanks and appreciation. So isn't that worth the cost of admission? It starts at $2 and goes up from there. So if you're interested, I'd love that. If that's not your thing, if you want to subscribe and maybe, I don't know, like tell a friend. That would be awesome too. Regardless, thank you so much for watching. Until next time, stay healthy, stay safe out there. Bye for now. Hello?
Hey, it's Ned. Networking team said the tickets are taken care of.
Oh, great. Thanks.
All in a day's work.
Bye.